Hey, what's up everybody? Welcome back to my course of object-oriented programming. Today I want to talk about hash maps. And this is going to be a couple of just a couple of lectures, I think. Just because there's so much to cover and I do want to go into a deep dive. So when we talk about hash maps, there's actually a couple things that we sort of have to do preliminary. So if you're familiar with ArrayLists, sorry about that. Let me just unclick this. Sorry. You have an array list, right? So an array list is a data structure. And one thing that is important for you to understand is that an array list is what we call contiguous memory. Contiguous memory. And what that means is that when you add items to an array list, the compiler itself has to allocate the next set of contiguous memory as it starts adding. There's an arbitrary number that the compiler uses that says, okay, when it gets to this limit, I'm going to add a couple of blocks more. So give you just a visual, right? So let's say you allocate an array list and you give it an initial size of 5, okay? And then you add an item. We'll just say it's an array list of int, right? You add an item, then you add another item. And when I say add, you're calling the .add function. And there's going to be a point in time when you call the add function and it says, uh-oh, I'm running out of memory. I'm going to have to allocate more. Now, the problem with this is that the next 5 or 10 blocks that it needs to allocate are not just going to magically free up, because outside of here, there could be some memory that doesn't belong to the array list that belongs to another variable or another data structure that you've declared in your program. So that means that the compiler actually has to do a little bit of extra work, because let's say the default, when it detects that it has to allocate a bit more of memory, it allocates double, right? So if it's 5, then it's gonna do 5 more, right? If there's a variable here, let's say there was another variable like an int, right, over here, right? Then the reallocation of this array list cannot go beyond or go past this int, which is a problem, because that means that the compiler is going to have to look for another set of blocks somewhere down, right? Because you think of memory as a stack, somewhere downward, where it could have an open space of 10 blocks. So it's going to say, well, I need 5 extra blocks here, but I can't allocate any more because there's an integer here. So I have to find an open space of 10. So somewhere down the line, it finds an open space of 10, and it says, all right, I found my 10 elements, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? It does its add, so it's going to do 4, right? And we're happy again, right? Yay, we're happy again. The problem again lies in that you're not going to have, if there's a variable somewhere down the line here, right? If it needs to reallocate again because you keep adding, remember, this is dynamic, it's going to have to go elsewhere and park now, instead of 10 blocks, right? It needs to do 20 blocks. And it constantly does this as you start adding items to the array list. And it's contiguous, because in an array list, everything is next to each other. That's why it's called contiguous memory. Now, what's the sort of the anti-hero of this array list? Well, what do we call non-contiguous memory? Well, non-contiguous memory has a special name. It's called fragmented. Okay, so fragmented memory. Okay, fragmented memory. And I'm gonna get to the hash tables. I want to set it up so that you understand why hash maps work the way they do, and we need to understand the underlying mechanism in memory. So fragmented memory is the opposite of this, meaning that the items in the data structure are not next to each other. An example of that is if you've taken C++ and bore that pain, you've learned about a data structure called a linked list. Now, a linked list is not it's not contiguous. It's actually fragmented. When you allocate an element, right? This element could be in memory location A. And as you add another element, it's not going to be right next to each other in RAM. It could be, it points to the next element. And it could be in memory location FA, right? So if you think about a linked list, you think about let's look at memory like this, right? In terms of a big block. So you got little blocks within here. A variable that you've declared could have some elements over here, then some elements over here, some elements over here. So it's all fragmented across memory. And you don't have, the compiler doesn't have to worry about allocating a big contiguous block if it starts running out of memory. It's actually, it's a little bit more efficient, somewhat. Okay, we'll get to that in later lectures. But the compiler itself, when it does a linked list, it doesn't have to worry about, uh-oh, I'm running out of space. I need another adjacent blocks because they have to be next to each other. Fragmented, I can fragment elements within the linked list. They're all fragmented by default, and they don't have to be right next to each other. So as I insert data, it's just going to find the first open one. So it's kind of like, you can think of this as a parking lot, where if you need a space, you can just find the first open space, and there it is. You can put the element in there, which again sounds a lot better, right? Versus the array list, it's sort of like you're parking a bus, and you need the size of that bus in the next parking space, which is the number of blocks in terms of elements. So these are the two types of data structures that we've dealt with in the past. Okay. Now there's also a third one, but I'm not going to talk about that one because that has to do with binary trees, but it's a little bit more advanced in terms of these concepts. So again, contiguous memory in ArrayList, and a fragmented memory, which is a linked list. Okay. Now, why am I talking about these different data structures if we're talking about hash maps? Well, what you probably didn't know is that a hash map is actually a combination of contiguous and fragmented. Okay. Well, how does that work? Well, I'm gonna stop this lecture here, and then we'll get to it in the next lecture. I know it's kind of a cliffhanger, right? But I wanted you to understand how memory works in terms of these data structures, so we can move on to the next step. So if you did get the concept, then we can move on to hash maps. So I'll see you on the next lecture.